Okay, so now we're going to be recording our lesson. We're going to be learning about climate factors today, specifically understanding latitude. And we're going to be talking about that today. Already in your Schoology Orange Weeks 3 and 4 folder, you were already supposed to take some notes that were released to you today at 11 o'clock. You want to have those pictures already done. It'll make life much easier today during our live session, as we're going to just be adding to those notes today. Now remember, this lesson is being recorded, so if I go too fast for any reason, feel free to go back and watch this lesson as soon as I publish it, okay? So let's look here at climate factors, and specifically we're going to talk about latitude. Today's learning objective, your I can statement is, I can use a model, in our case a picture, to describe how the latitude of an area influences its climate. Now, when I see that word influences, that means changes, how it makes a change to its climate, okay? So when we're learning here today, it's important for us to be able to understand what latitude is. You should have already drawn this picture in your notes. If you've not, I am going to be on this page for a little while today, so you can get started on this picture right now. So in our notes, we need to write latitude and location. It's important for us to understand that latitude is talking about the location of an area, of a place in the world. So when we're looking at latitude, we want to make sure, uh-oh, I need my highlighter. Thank you. We want to make sure we know that latitude is talking about the location of an area. So right now on our pictures, Ms. Neville's highlighting the latitude of each area here. Yes, it's important that we understand latitude is location. And the equator, which Ms. Neville just highlighted, is very important in helping us understand our latitude. It's important that we understand that the equator dissects or bisects our world into two different parts. Trying to get my marker, give me a second. There we go. We live in the northern hemisphere. And the area below our equator is our southern hemisphere. Okay? Our northern hemisphere and our southern hemisphere. So when we're looking here at the equator, we need to make sure we understand that we're talking about location. We want to remember, when we talked about climate zones, we have to remember that the equator is the warmest part of our world. The equator and the area around that equator is the warmest part of our world. So it makes sense then, what we wrote here is our second little star statement, important point we don't want to forget, that latitude is not temperature. We are not talking about temperature when we see those degrees there. To be more specific, we could say 60 degrees north, 30 degrees north, okay? We're talking about where it is in the world, the location, not the temperature. Another reason we know we're talking about location is because Ms. Neville just told you that the equator was the warmest part of our world. So it wouldn't make any sense then for the equator to be 0 degrees for temperature. No, it's talking about the location from our equator. The closer I am to my equator, the smaller my number will be. The farther away I am from my equator, this is my tropical region. The farther away from the equator I am, like here at that North Pole, 90 degrees north, this is not talking about temperature. This is talking about the location of the northern polar region, the Arctic. And so the farther I am away from the equator, the larger my latitude becomes, the larger my coordinate. So this is our, and I'm going to use the correct color, I'm going to use my blue. Yep, this is our polar region. And this area here in the middle, does anyone remember? We have tropical, we have polar, and what's that area in the middle? Someone turn on their mic and let us know.
Temperate.
The temperate region. So we have that temperate region there in the middle. Okay. So we see the farther we go away from the equator, the larger our latitude coordinates become. Remember, latitude is talking about location, not temperature. Okay. So I wanted us to look at some climate review today. We're going to look at how to read some weather maps, and we're even going to look at two of the questions that your class struggled with the most. Now remember, Miss Neville's job is to guide you towards the correct answer, not give you the correct answer. So what we're going to look at today is how to read a weather map, a weather graph. I want you to pay close attention as Miss Neville models to you her thinking when it comes to talking about what kind of weather currently is happening or predicting future weather conditions. So let's look here. We see this is a line graph. I know this is a line graph because there's a big red line here. And it shows, the title tells me that this line graph is measuring the barometric pressure over a 7-day period. Now, what is barometric pressure? Well, we want to make sure we understand that barometric pressure is just a scientific way of saying air pressure. Yes, barometric pressure and air pressure are the same thing, okay? So we're looking here at the air pressure. The air pressure on this graph starts off high, then it becomes low, then it starts to rise back up again and go high. The question that Ms. Neville asks you here using this line graph is, on which day did a thunderstorm most likely occur? Now, there's some things I need to think about as I'm answering that question. I need to make sure I know that a thunderstorm is severe weather. And what kind of pressure system happens with severe weather? Can someone turn on their mic and let us know?
Low.
Very good. A low pressure system is going to happen with a thunderstorm. And I also don't know what that word occur means. Happen. Yes, occur is just a synonym, another word with the same definition, a synonym for happen. Okay? We also want to make sure we understand here. So basically, we want to make sure we see that there was a high pressure system here. Then it went down to a low pressure system, and then it's rising back up to high. It's important for us to understand where, someone turn on their mic, based on this graph, on which of these 7 days would a thunderstorm most likely happen? Someone let us know.
The 30th. 10.912.
Very good. October 30th, 2012. October 30th, 2012. So when we look here at number 4 on your first reading weather maps practice, where you had 5 questions you needed to answer, only 47% of your class answered all 4 of these correctly. 5 of these correctly. What we wanted to do is we wanted to match the weather conditions with the correct area. Here are some things to think about if you're doing your second attempt. I want to make sure I'm looking at the correct areas. Idaho, this is Nevada, NV, Colorado, CO, Texas, TX, and the coast of Virginia is where that black line is over here by VA. That's where the beach is, coast, okay? When we're looking here, we got to make sure we understand what kind of weather comes with high pressure systems and what kind of weather comes with different types of fronts. Remember, the difference between a stationary front and an occluded front is time. A stationary front that's also happening at the same time as a low pressure system, like here in Nevada, that's going to be some pretty bad weather for probably a long time. Then we look over here, okay, where Virginia is. There's another stationary front, but now it's happening near water, and there's a low pressure system. What kind of weather is occurring there? Then here in Colorado, there's a low pressure system, but there are no fronts. Whenever I don't see fronts, that means there's no precipitation, or it's least likely to be raining or snowing in that area. So if there's a low pressure system there, but there's no rain, wonder what that would look like. So I want you to think through. You have to go back and be able to look at each of these symbols as you're working through this today. Our next one that a lot of you missed, and not as many, as only 63% of you missed it this time, was we were looking at this graph that shows the amount of snow that happened in Toronto, Canada. And they measured it for 3 different years. The green line shows us the amount of snow in centimeters in 2011. The blue line shows us the amount of snow in 1975. And the red line shows us the snow that happened in 2010. Ms. Neville wants you to use this graph to tell me, in which month did a stationary front most likely happen? Remember, a stationary front means precipitation, in this case, snow, for a long time. So we want to make sure here, that the most snow is going to happen when that stationary front is happening. Hint, hint, hint. Hopefully you're going to do better on your second attempt. And if you have any questions, please email me so I can set up an individual tutoring time with you. Now, let's talk about your assignment for today. Let's talk about your assignment for today.